we are continuing, guys. So in this problem, this is a bit tricky, so you need to spend a little bit time looking at it. Now this one can actually give you a challenge, but if you look at x squared plus 2, if you remember in the previous video, not in the previous, in the previous example, I explained that when you have x squared plus 2, it tells you that for whatever value of x, this expression, the numerator is always positive. Okay, so now when you have a denominator of which x is x squared plus 2, you know that whatever value of x you put there, this expression will always be positive. So in this case, and in this case only, you are allowed to multiply with your unknown, because even if your factor here or your expression here, your denominator is unknown, the value of x is unknown, but you know that for whatever value of x, this will always be positive. This factor here, this expression will always be positive. It's not necessarily a factor, it's an expression. So you can go ahead and multiply by it, okay? So if you multiply the left and the right hand side with this, so you'll have 2 minus x over x squared plus 2 multiplied by x squared plus 2 is greater than 1 into x squared plus 2. You multiply the left and the right side with the same factor, so your sign remains the same because you know that this is positive. You don't change the sign. So this therefore cancels that, okay, and then you remain with that. Then you remain with 2 minus x is greater than x squared plus 2, which you can take this to that side. So because you want your x squared to remain positive, so if you take this to that side, you will have a positive x. You take this to that side, you will have a negative 2. So they are no longer the side, and then this side you are remaining with 0. So now your expression is now x squared plus x. 2 minus 2 is 0. So this 0 is bigger than all this. So meaning this is less than 0. Why? Because 0 is bigger. So then when you factorize, you'll have x into x plus 1. Okay, is less than 0. And then this is the same as x plus 0 or x minus 0 into x plus 1. Don't let it confuse you, okay? And therefore, you have your two factors to test. And then here you'll be having, for this factor to be 0, x must be 0. So x will be 0. And then for this vector to be 0, x will be 1. Now remember, here x can be any value, because anything squared will, if you want to find for which value would this be 0, whatever value that comes out of x squared will be positive. So your denominator is not going to be 0. So you are safe from that. So you're going to make your number line. Okay. You're going to test your positive 1. You're going to test your 0. Okay. And then you're going to make your dotted line like that, as we always do. But what are we testing this time? We are testing only these two. You have x plus 0, you have x plus 1. Okay, so actually your x has to be negative for this vector to be 0. So meaning your now testing numbers are different. It's not positive 1, it's actually negative 1. Okay, so it's like this. It's like this. You'll have your negative 1, you'll have your 0 here, you'll have your positive 1. But what are you testing? You are testing negative 1 and you are testing 0. So this side you can even have your minus 2. Okay, all right. Now you will then say if x is minus 2 plus 0 is negative. Minus 2 plus 1 is negative. If your x, what is between negative 1 and 0? Between negative 1 is negative half. Okay, negative half. Okay, so if you have negative half plus 0 there, you have negative. If you have negative half plus 1, you have a positive. All right, and then this side, if you have 1 plus 0, you have positive. If you have 1 plus 1 there, you have a positive 2. And then because you're multiplying these two together, you're gonna say negative times negative will give you a positive. Negative times positive will give you a negative. Positive times positive will give you a positive. Okay, so now you come back here. You are looking for this expression to be less than 0. Okay, you're looking for it to be less than 0. So anything less than 0 is here, negative. So this is not your expression. Your x doesn't lie there, it only lies there. So you are then going to say your x is less, or is it equal? Is less than 0, but your x at the same time is greater than negative 1. Okay, now question, can we say x is equal to 0? If we say x is equal to 0, we'll have 2 minus x, which is 2 minus 0, which is 2, and then we'll have 0 squared plus 2, which is 2, and 2 divided by 2 equals 1. It's not greater than 1, but it's equal 1, so we can't say equal. The same way here, we can't say x is equal to negative 1. If we say 2 minus into 1, negative 1, that will be 3, and then that will be 3 there, and then x squared, negative 1 squared will be 1, 1 plus 3, 1 plus 2 will be 3, 3 divided by 3 is 1, but 1 is equal to 1 is not greater than 1. So we cannot say equal, so our answer remain like that. Okay guys, all right, so let's just quickly remove this. Remember, the key here is to remember that when you have x squared plus 1, for whatever value you put there, you are going to have a positive outcome, which means that you are allowed to multiply both sides with it, because you know it's positive. Therefore the sign doesn't have to change. It is a vector of which the sign is known. Okay, all right, now we are done with that. I know it's a bit to take in, especially this one. We are going to the next one. Now, the next one isn't that challenging, guys. The next one isn't that challenging. So, bear with me here. Okay. So, the next one says x to the power 4. Okay. let me just remove this, x to the power 4 minus 7 x squared minus 18 is actually less than 0. Okay, less than 0. Now, whenever these powers tend to increase like that, people tend to be confused, as because most of us we used to x squared, and then we factorize this. If you ever find yourself confused, you can just say let x squared be k. Right, therefore x squared, x to the power 4 will be k squared minus 7k minus 18 is less than 0, so that you can be able to factorize it. In this case, you'll have k into k, and then you look for the factors of 18 that can give you 7, which is, you have 1 times 18, you have 2 times 9, and then this one does give us 7, so you'll have 9 and 7. Okay, because it's positive, we must have positive and negative. Okay, you'll have a minus 9k plus 2k. Okay, but remember, x squared is the same as k, so you can have x squared plus 2 x squared minus 9 is less than 0. Okay, you can have it like that. Okay, so once you're here, you can then go ahead and look for the values for which this vector is 0. Okay, so if you look at this expression, right, if you look at this expression will be positive for whatever value of x you put. This will be positive for whatever value of x you put. All right, so meaning whatever you need to do, you need to make sure that this is negative, because you know that positive times negative will be less than 0. But if this is positive and this is positive, you're gonna have a positive vector product, and then a positive is greater than 0. So, but this you can't really do much with, because no matter the value of x, you will always remain with a positive. It's similar to the previous example, it's similar to that numerator there. So you are not only working with this, you are making it negative. So you want x, let me come here, you want x squared minus 9 to be less than 0, because if it's less than 0, you can have positive times negative, then it will be negative, and then you'll have the sign respected there. So then in this case, you'll then have x squared is less than positive 9. All right, and then the square root of x squared is x, the square root of 9 is 3. Okay, so you'll have a positive and a negative 3. All right, then when you have a positive and a negative 3 there, because out of square root you take plus minus, you're going to check if I have x squared as positive 3, I'm gonna have 3 squared, which is 9. 9 minus 9 is 0, right? And then if you have a positive or a negative, it's still the same. So now, if you have 3, you will have 0, and this will be not correct because you want less than 0. So meaning x must be less than that. So you can go ahead and test it. You can go ahead and test it and say you have a positive 3, you have a negative 3, you will have a 0 there. But you are testing this, you are testing that. Okay, And then you want to find out if x is greater than 3. Therefore, you will have a bigger number, minus 9 will be positive. Therefore, your x is less than 3. Okay, your x is less than 3. So the answer here is x is less than negative 3 actually. Is less than negative 3. Because if you have less than 3, let's say you have 2. 2 squared is 4. And then 4 minus 9 is negative. So it means even positive 3 is correct. So then you know that your x is this side. Your x is less than 3. Let me put it this way. Your x is less than 3. But at the same time, your x is less than negative, is bigger than negative 3. Okay, so your x is here. I hope that you guys can understand why that is. Your x is less than positive 3. So it means it's less than positive 3. At the same time, the x is less than negative 3. Less than negative 3. So if you have negative 3 here, you will be having anything that is less than negative 3 is this side. And that is not correct because negative 4 is less than negative 3. But if you plug it there, you're going to have negative 4 squared, which is 16 minus 9 is going to be a positive. So actually, your final answer must indicate that your x is here. Your x is greater than negative 3, but your x is less than positive 3. So this is your final answer. So this just gives you the values that you must test, the positive and negative 3. The positive and negative 3 that you're going to test. But your answer lies here. Because anything out of these boundaries is going to give you a positive here. Therefore, it means that you will have a positive, and then when you come here, you'll have a positive times positive, which is positive, and then this is no longer okay with that. But if your value becomes here, then you have this factor as negative, then this is becoming satisfied. Inequalities can be a bit challenging. The thing with inequalities is that they don't only rely on computational what can I call it? They don't follow a computational steps. You see, they also rely on logic, right? Like here, you need to apply logic. There are expressions in mathematics where you know, step 1 I do this, step 2 I do that, step 4 I do that, so on and so forth, right? And then you will get it correct if you follow the steps and you respond to the steps accordingly. But then in inequalities, in addition to that, you need to apply logic. I'm sure by now, if you compare, if you look at from the first example that we did to this point, you will realize that they are not responding to the same method. Like you can't use the same method that you solved the previous one and apply it to the next one and solve it. You need to use logic. You need to look at the expression and think and try and analyze it. Okay, so we are doing 2x minus 1 over x plus 1 squared is less than 0 next. Just gonna remove it from here. So in this one, you have the entire expression being less than 0, meaning you have the entire expression being negative. Okay, but at the same time, you can see that whatever value of x you put, you are going to have a positive denominator. Okay, so this tells you that you only need to work with the numerator such that it is negative, such that it is less than 0, so that you can say negative divided by positive is negative. Negative divided by positive will give you negative, because anything less than 0 is negative. At the same time, you can immediately see that your x cannot be equals to 1. I mean, cannot be equals to negative 1, because negative 1 plus 1 will be 0, 0 squared will be 0, and then therefore the entire expression will be undefined. If x is equals to negative 1, then you have undefined. Okay, so you cannot have that. So that will be your first answer. But if you look at this and you apply logic, you will realize that for whatever value of x you put, because of the square, the denominator will always be positive. This will be positive. So let's work on making that negative. So if this must be negative, it means 2x minus 1 must be less than 0. It means 2x must be less than 1 if we take this one to that side. And then if we divide by 2, we divide by 2. It means x must be less than half. Alright? Must be less than half. You wanna test it? If we put x is half, we have 1 minus 1, which is 0. Alright? So 0 is not positive or negative. So we want this to be negative. So if we have any value that is negative and you multiply by 2, you will have a negative something, and a negative 1 will give you a negative. That is where the logic is coming. So then you have this as your final answer, in addition to x is not equals to negative 1. Okay. So x is less than half. So, right. So if you have your number line, you have 1 there, you have 2 here, negative 1, negative 2, you have 0, you have 1, you have 2 there. Okay, so that will be your half. So your x starts here, and then it goes there. But let's see if x can be half. Half times 2 is 1. 1 minus 1 is 0. So you cannot have x as half. It's not equal to half. It's not equal to half. It is less. Okay? It is less. So that is your answer there for this guy over there. Now we have the last example that we're going to do for the day. We have the last example that we're going to do for the day. And this is the last video on the examples of nonlinear inequalities. So if you watched the previous video and this video, you would have concluded there, and then you can just straight up go to your exercises so that you can practice. Okay, so that you can practice, and then you will be ready for your exam. The last example that we're going to do is 2x minus 3 as a factor, x plus 1 as a factor, 3 minus 2x as a factor. Oh boy, very interesting, very interesting. Divide by x squared minus 4 as a factor, and they said it is less or equals to 0. They've already put it in standard form. Okay, and that we will get to that far. Okay, all right. Immediately, you can see if you have x is equals to 2, you will have 2 squared minus 4, which is 4 minus 4, and that is 0. So x cannot be equals to 2 because you will have undefined because of this denominator over here. Right, now if you examine your expression, you will realize that 2x minus 3 and 3 minus x a bit similar. In fact, if you factor -1 out, if you say minus 2, if you say minus, you'll have 3 minus 2x into x plus 1, 3 minus 2x all over x squared minus 4 is less or equals to 0. Alright, you will realize that this and this is the same now. Then you can have minus into x plus 1 into 3 minus 2x squared over x squared minus 4 is less or equals to 0. Okay, you can either multiply this side by negative and that side by negative, and that side will change, or you can just absorb this negative into here, and then you will have, if you absorb it into here, you will have -1, okay, you'll have -1, negative x, so you'll have negative x, -1 into 3 minus 2x squared over x squared minus 4 is less or equals to 0. The reason why we want to bring this positive here is sort of, we know that for whatever value of x we put for this factor, this will always be positive. This is the game of science. This will be positive. Okay, that will be positive. Now, then we'll be remaining with this factors here only. Okay, and then these are the factors that we can then put to the test. Then you would have the value of x for which this expression will be negative, will be 0. Therefore, if you have -1 for x, you'll have minus into -1, which is +1, plus 1, which is 0. So you'll have x equals -1. That will make this expression 0. For here, if you have 2, if you have x is equals to 2, that will make this expression 0. Okay, so now you find the two values for which the factors are 0. I think that is step number 4 in the introduction. Then you will make a division line, because this is less than 0. You want this divided by this to be negative, because negative times positive will be negative. Okay, so you will be testing -1 1 and positive 2. Okay, so you'll be testing those factors only. This one you already know is positive. So you have minus x minus 1, and then you have x squared minus 4 as it is. So here you could possibly be having negative 2. Here you could be possibly be having 3. These are just values that I put to guide us. Between negative 1 and 2, you could possibly be having, we can put 0, or if you go 2, you'll be 1, and then negative 1. So you can put 0. Okay, so those are our imaginary values that we're going to be using, which are on the other side. So if you put minus 2 for x, you'll be having positive 2 minus 1. So you'll be having positive here. If you put minus 2 for x here, you'll be having 4 minus 4, which is 0. So the sign is positive or negative. Okay, so because it doesn't give us a conclusive answer there, therefore we're going to go ahead and say minus 3. So if we put, then let's go back and test with minus 3. If we put minus 3 here will be positive 3, minus 1 will be positive. Okay, and then if we put negative 3 here, we'll have positive 9 minus 4. This will be positive. Okay, if we put 0, you'll have negative there. If you put 0, you'll have a negative there. If you put 3, you'll have a negative there. If you put 3, you'll have a positive there. So now it is this divided by that. That is already positive. It is this divided by that. And you want a product of negative, so that you can say negative times positive to be negative, which is less or equals to 0. So now you're going to say this divided by that. Positive divided by positive is positive. Negative divided by negative is positive. Positive divided by negative is negative. Meaning our answer only lies here. Okay, our answer only lies there. Now we are then going to say x is greater than 2. It's greater than 2. We can't say it is equal to 2 because of that. So we'll be having only one answer. We'll be having only one answer. So that marks the end of nonlinear inequalities. Yes, you can say, phew, yeah, that was a lot. So guys, watch the first video which introduces the section. Watch the second video which we did the examples, the first few examples. And with this third video marks the end of the examples that we are doing. Now, it is now your duty to go into the exercises and practice with that. Whenever you come across the challenges, visit the first video, the second, and the third. And if that isn't helping, comment below with that problem, and then let's tackle it together. Who knows, I will be doing a video on that program, on that problem, and then I will be showing the solution here. Okay, like always, like, subscribe, and yes, don't forget to recommend this to your friends and family if this is helpful for you. If it's not, don't mention it. Yes, I hope that it is helpful. Okay, thank you guys for watching. See you in the next section.